Hey, you all. Thanks for being here for math today. I appreciate you. I know you're doing a lot of hard work. And this is hard math in third grade. So I know you might be feeling frustrated, but I appreciate you just plugging along, asking questions when you can, coming for help when you can, all right? We've learned a lot about area and perimeter in the last week. So let's just kind of think about, right? Area and perimeter, how are they different, right? The perimeter is around the outside of a figure. The area is on the inside, right? It's the number of square units on the inside. Thinking about other kind of vocabulary words that we might use, we've talked about the word adjacent, right? Those are lines that are next to each other, right? So those darkened lines would be adjacent. When we find the area of a figure, we're going to multiply, right, the adjacent sides. We also call those side lengths. We also have learned a little bit about figures that don't look like rectangles, right? If we were to erase that part in the middle, how we can actually find the area by decomposing or breaking it down into smaller pieces. So you've learned a lot about area and perimeter in the last week. And now we're kind of ready to move on and to take what we've learned and apply it in kind of real world situations. All right. So we're going to work in our math journal on page 323. And we're going to learn about why learning about area and perimeter might be really important in those real world skills that we have. Okay. So page 323, we're going to solve some word problems. I'm going to do some drawing on my my dot board there so that you can see the shapes, and then we'll transfer those shapes into our math journal so that you've got a picture to go along with this, okay? So the directions ask us to solve this, and it says to circle whether you need to find a perimeter, an area, or an unknown side length, and then draw a figure to represent each situation. So we've got a few things to do here. Okay, so let's take our time and let's think our way through this. Okay, it says the dimensions of a rectangular picture frame are 9 inches and 6 inches. What is the greatest size picture that would fit in the frame? So let's go back and let's bracket our question, right? And we're looking for what's the greatest size picture that would go in the frame, okay? So let's draw that frame. 9 inches and 6 inches are the side lengths. So if I kind of come over here, I'm going to move my book a little bit. And if I draw something that's 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the other side length is 6. And I'm going to complete that and make my rectangle. Okay, so there's my shape. Don't have a ton of room here. I want you to be able to see up close. Okay, so there's my rectangle. Okay, and they're asking what picture would fit on the inside. Okay, so am I looking for trying to find the perimeter around the outside? I don't think so. I'm not going to say that. Am I looking for the area on the inside? They've given me the side lengths. One is 9. One is 6. Okay. Or am I looking for an unknown side length? Well, they gave me the side lengths, right? So I'm not looking for an unknown. I have the information. So this is going to be an area problem. And remember, when we're solving an area problem, we multiply the side lengths. So let's take a minute and let's transfer this shape onto this white space right here. Okay, and we're going to redraw it. Obviously, it's not going to be exactly the same, right? But we know what shape it is. It's kind of longer in one direction than it is in the other. And I'm going to label my side lengths. Okay, so we're looking for what's on the inside. Okay, and remember, area always has squares, right? The number of square units on the inside. This one is talking about inches. So I know that my label is going to be square inches. So I'm going to write that down. I'm just going to use the abbreviation for square and the abbreviation for inches. Okay, and we know we're going to multiply those side lengths, those adjacent lines. So we're going to write 9 times 6 equals something, right? You should be practicing your multiplication facts to get faster with those. Your fourth grade teachers are going to expect that you know all of them. The hope is that you know all of them by the end of third grade. Okay, remember, 9 times 6 would be 9 groups of 6. You could flip it around and say 6 groups of 9. Now that I see a 9, I know I can use my numbers, my finger trick, right? If I have 9 as one of my answers, right, I'm going to put down, right, my 6th finger. 1, 2, 3, 4, 5. My thumb is my 6th finger. Okay, and that finger that's down separates the tens and the ones in a number. So here are 5 tens and 4 ones. 5 and 4 is 54. So our area is 54 square inches on the inside. So the greatest size picture that would fit in the frame, right, could be 54 square inches. If it's bigger than that, it's not going to fit. Okay, I'm going to erase this drawing and we're going to keep moving on. Now, sometimes we encounter problems or questions and we don't know what some of the information means, so we might have to look it up. Okay, we haven't gotten to the part in our math journal where we're talking about shapes other than rectangles. Okay, so there's a shape in here that you might not know what it is, and I'll explain that to you. Let's read number 2. It says a garden has the shape of a hexagon. Okay, a hexagon is a 6-sided shape. So I'm going to write 6 sides right there. Okay, and the hexagon would look something like this. Okay, now that's if all my sides were the same, right? And maybe they won't be, and maybe they will. Okay, so that's what a hexagon is. It's a 6-sided shape. So this is a garden. It says each side of the garden is 5 feet long. Oh, so they are the same size. Each side of the garden is 5 feet long. How much fence is needed to go around the garden? So I'm going to bracket my question there. How much fence is needed to go around? Okay, well, we're talking about feet. So how many feet is going to be our label? Okay, there's the word feet. If you want to use the abbreviation, it would be FT with a period. Okay, either one is fine. So if I have a hexagon and it's a 6-sided shape and each side of my garden is 5 feet long, and I need to figure out how much fence is going to go all the way around it. Okay, I'm not looking for anything on the inside, so it's not going to be area. They gave me all the sides, right? Because each one is 5 feet long. I have to know that there are 6 sides because I need to know what a hexagon is. So this is going to be a perimeter question, right? So what do we do to find the perimeter? We add up all the sides, right? These happen to all be the same, so they're equal. I could also do some multiplication here. So I could do 2 different things. I can add up all the sides. So there's 6 sides. So 5 plus 5 plus 5. There's 3 sides. I've got to do 3 more. Right? 5, 10, 15, 20, 25, 30. So I know I'm going to need 30 feet of fence to go around this garden. I could also do 6 groups of 5 because they're right equal groups. And it would be the same thing, 30 feet. So either way, I could add them together, right? This is repeated addition because these are all the same. So I can do multiplication because they're all the same. Okay, so here's the difference. This is an area problem. This is a perimeter problem. We're figuring out something around the outside of something, right? We're going to finish this page, and I want you to really be thinking These are things that could happen in real life. You might need, right, some kind of a picture frame, and you need to know what size picture you can put inside because you're going to order pictures, right? You might have a garden and you need to add fence to it. Let's see about number 3. The length of a water slide is 9 yards. Ooh, the slide is 2 yards wide. So how much of the surface of the slide must be covered with water, right? The surface would be the top of it, just like if we think about looking out at the water, the surface is what we see. We don't see what's underneath. Okay, I'm going to draw this picture. The length of a water slide is 9 yards. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And then it says it's 2 yards wide. So there's 2. Okay? And incidentally, a yard is 3 feet. Okay? So think about the size of this water slide. I'm going to connect and finish my figure. There's my rectangle. So there's my slide. The question is, how much of the surface of the slide is going to be covered with water? So the surface would be this whole area right here. Okay, so I'm looking for something like that. Is that going to be a perimeter problem, an area problem, or a side length problem? Missing, or I'm trying to find an unknown side length. Right? I have the side lengths. They gave me those, right? They're not asking me for anything around the outside, but they're asking me to find covering the surface, the inside. So that's an area problem, right? So I'm going to transfer this drawing onto my math journal so that I have a visual picture of what I'm doing. That's why this math dot board is so great to have, because you can draw things and then you can put them in your book. Okay, so we know that to find the area on the inside, all we do is multiply those side lengths. So 9 times 2, I know my doubles really well. That's 18. Okay, our unit of measurement was yards, but remember, it's on the inside, so we have to add square yards. That's the abbreviation for yards. Okay, so you really want to be thinking, what are they asking me to do? You might need to know this. What if this were a sandbox that you built and you need to know how much sand you need, right? You might need 18 square yards of sand to fill up the sandbox. This is real stuff that real grown-ups have to think about and have to solve these problems. Okay, we're going to try one more, and then I'm going to let you go. Okay, Mr. Schmidt is installing 32 cubbies in the hallway. Okay, cubbies are just like little boxes. He puts 8 cubbies in each row. How many rows of cubbies can he make? Okay, so think, are we asking about a perimeter around the outside? Are we asking for the area on the inside? Or are we trying to find a missing side length? Okay, if I draw 32 cubbies, right, there are 8 cubbies in each row. Okay, so if I were going to draw cubbies in each row, here's 1, 2, 3, 4, 5, 6, 7, 8, right? But cubbies aren't circles, they're squares. We can stick shoes and things in them, right? But we've done problems like this before where we had 32 of something and they were in equal rows. So think back to what you learned a long time ago, before Christmas time, right? Let's see. If we know we have 32 of them, 32 all together, right? And they're 8, 1, 2, 3, 4, 5, 6, 7, 8 in one row. Okay. How do I find this side? I don't know how long it is. How do I find that? When I find the area on the inside, remember, I multiply. So we've talked about what's the opposite of multiplying? It's dividing, right? So we're going to divide to find our missing side length. Okay, so this is a side length question, not perimeter, not area, right? They've given us the area really on the inside. We don't need to know anything about the perimeter. They're not asking us that. So we're going to take our total on the inside, and we're going to divide, and we're going to count, remember, count by 8s up to 32. You can use the opposite side of your number path, right, to circle groups of 8. How many times do we do that? Let's look and see. Let's circle one group of 8. And I'm going to circle another group of 8 to count those boxes, and another group of 8, okay, and another group of 8. There's 5 there, and 6, 7, 8. Okay, so how many times did I do that? How many groups of 8 do I have? 1, 2, 3, 4. I count by 8 4 times to get to 32. Right? The question was, how many rows of cubbies can he make, Mr. Schmidt? He can make 4 rows of cubbies. Okay, so we're going to draw that picture again. 32, and we've got 8 on one side. We don't know how long that is, right? So we can draw that into a rectangle. We know now that it's 4. Okay, so taking what you've learned about area and perimeter and solving real-world problems is something you'll do your entire life. All right, take your time with today's assignment. Focus on what you're doing. Find a quiet space. Okay, and if you need help, you know where to find me.